hello, everyone. I hope you had a nice lunch. I had a great breakfast right now because I'm running a bit late with my times. This is Marcel. He worked at Google. He's in the Go team.
Yeah.
So very awesome to have you right now.
Still at Google, yes.
Awesome.
Yeah.
He's from Zurich, Switzerland, and he's done a lot of work in testing, error handling, and the Xtest repository. Now he's working at the development of Q, a constraint-based aspect-oriented data language, I think.
Yeah.
Is that correct?
Yeah.
And previously he worked at Search and Borg, which is Google's large-scale cluster manager. So the charity you chose was Jonathan Jackson Foundation. Would you like to say anything about it? Any words?
Yeah, sure. So Jonathan Jackson is a friend of mine. So what I like about charities is if I know that every dollar goes to the people in need and not to overhead. So he is paying for all the overhead himself, and he has already lives in Kenya for quite a while now. He grew up there too, and he is basically now with the whole COVID situation, it's causing a lot of hardship for some communities. So he's helping those communities with boots on the ground. And also trying to lift them, give them jobs and get them back on their feet, basically. So this is more like an emergency response kind of thing, although he is, trying to help the communities there locally. And it's, so seems like a good cause.
Yeah, definitely. So your talk is on better APIs with shareable validation logic. I think this is a topic we can all, or most of us at least, will find very interesting. So go ahead and start your talk.
Okay. Yes, so thank you for the introduction, Paula. So I've been on the Go team for a while now, so there are some hints of that around me, I would say. So now when we're talking about better APIs, there's a lot of aspects that go into making an API good. And there's also many things you could call an API even, but today I'm really talking about focusing on shareable validation logic. So what do I mean with this? Well, let's look at an example first. So this is a typical setup where you have a server that can be written in Go that receives requests from a client. And that client bases the request on some input like YAML or JSON file. So an example of a server like this is like kubectl, like the controller command line tool for controlling Kubernetes. But there's many tools like this in the Go ecosystems and applications where you basically have a client that takes some input, sends it a request to a server. So basically, if a server is well behaved, it will validate that the incoming request is valid. But really, before you're sending a request to a server, ideally you will want to validate it on the client as well. So somewhere during, processing in the client. But really, if the input to a client is YAML or JSON files, for example, you really want to catch any errors that you're writing in this JSON or YAML files as early as possible, ideally already in the editor, right? So the whole point of this is that you want to fail fast. So how can you achieve that? Well, one way that has been approach that has been taken is that you extract the validation logic from the server, put it in a separate package that can then be used in clients. So this has various problems. So first of all, this is not very conducive to a polyglot environment, something that is pretty often occurring nowadays, and also you might run into versioning issues. Like you could have if the client uses the validation logic of an older server, it might still send wrong requests, even though it uses this shared package. Also, using these shared packages within editors is not always that easy or straightforward. It's totally doable, but make a plugin for that. But it's more work. So an approach you see more often nowadays, so in the Kubernetes world, this is done quite a bit, but this is becoming more pervasive, is the use of OpenAPI or JSON schema, basically to declaratively specify what your requests can be in some schema, right? So basically, You have the validation logic still in your server, but you also explain in the schema like what kind of requests are valid. So the client, which can now be in any language, as long as there is some kind of library to interpret the OpenAPI or JSON schema, as long as there's some library like that, you can validate that the requests you're sending to the server are properly formed. So this also makes it a little bit easier to start supporting this in the editor side of things. However, now we have the next problem, like how do you keep the validation code in your server in sync with the schema? So that's what I'm going to talk about today a little bit. So the solution that I'm focusing on today is to use Q, which is this language and system I've been developing. I'm assuming most of you are not familiar with it, so I'll give you a short primer. So firstly, Q is a language that can represent both data and schema at the same time. And it makes the data and the schema look very much alike. And it unifies as a unified model for both. So secondly, it's a command line tool. So you can actually combine and merge like schema data of various formats on the command line and do various operations with it. So it's also a logic engine, or maybe a better word is unification engine. So in order to combine schema and data of different types, if you do it willy-nilly, it becomes unprincipled very easily. So there's actually like some rigorous formal system behind it, which is implemented in this unification engine. So also then there's a rich set of Go APIs and Go integration, which I will demonstrate in this talk. So let's look at the Q value. So here on the right, we see some JSON and the equivalent in Q on the left-hand side. So this is pretty straightforward. Q is basically a JSON superset, and on the left-hand side, you see it adds some syntactic sugar. So it's a nicer way to write JSON in some way. So now look at types. So on the right, we have a typical Go type. On the left, this is represented in Q again. So now it really doesn't look like that much like Go anymore. So syntactically, it actually looks a lot more like JSON, or the simplified Q variant of JSON again. And there's a reason for that. So really in Q, types are values. So if you look at the first field, the value is string, which is equivalent to the Go type string. So capital is true, which is equivalent to the Go value true. But you can also have things in between, like greater than 3 million, which is a constraint. That's something that's also familiar in OpenAPI. So on the right-hand side, you see the OpenAPI equivalent of Q on the left-hand side. Now, another important thing is that Q orders everything. So all the values, including configurations, are ordered. So if you look at the previous examples, here they're ordered from more specific to less specific. So at the top, you have municipality. An instance of municipality is large capital, and Berlin is an instance of large capital in turn. So you go from more specific to less specific. And this is generally how Q works. So if you can do it with configurations, you also have to do it, should be able to do it with values. So here's some example of that. So you can see that 8 is an instance of greater than 2. So what greater than 2 means really is any number greater than 2. So 8 is an instance of that. But you can also combine constraints, like less than 5 greater than 2 becomes any number between 2 and 5. So 4 is an instance of that, for example. And another important aspect of Q is that whenever you combine two values, both single values or configuration, there is always a single unique answer. So what it gives you is merging two values in Q, you have these mathematical or properties, if you will, associative, commutative, idempotent. And really, this is just a fancy way of saying that order doesn't matter. So I can take any two Q schema values, whatever, like dump them together, and I will get always a single unique answer. So let's demonstrate what I mean by that by an actual demo. So I've recorded, not sure if that's a good idea, but first time I'm trying this. So I'll try to keep up with the recording. Anyway, so here you have two files, a JSON and a YAML file, both specifying a restaurant. And I want to combine these two into a single map of restaurants. So I do that by running qdef. So I did that before for JSON. So Q exports basically generates JSON, but I can now also generate YAML by changing the output format. And you see here that basically it neatly combines these two files in one. So what if I combine two files with conflicting values? So for example, let's say for some reason I have two files with the same restaurant and they have a conflicting value for cuisine in this case. So again, I'm exporting the two, and lo and behold, now it gives an error. So I can click on the file links that it gives, and it will jump to the error in any of these input files. So that's what you're seeing here. So Dutch and contemporary, not the same thing. So it will not pick one, it will just throw an error. So now let's see combining a schema with a value. So Q basically recognizes that something is a JSON schema if it has this schema field with the right value. That's the recommended way for JSON schema to do this. And let's see if we merge these two. So we use def here to basically show what the schema looks like. Like I find JSON schema and OpenAPI a little bit hard to read, so I like to convert it to Q. And in this case, def means define, so just print out the schema. And here you see that the Q representation nicely maps to the YAML file. So now I run fed to just check for errors. And there's two errors. So let's click on some of these links to see what's going on. So here we say the seats value 12 conflicts with something else, which is the maximum of 10. So that's correct. 12 is larger than 10, so that's not correct. So let's correct that. And then the other problem is seats is required, but as you can see, the third element doesn't have seats. So this was a typo. We need to remove the dash, and then it works. So you run it again, and the errors are gone. So now let's combine to schema. So let's say, for example, you have an older schema of the same API. In this case, it's represented in JSON. And if you look at it carefully, it has actually different number ranges. So let's see what that does if we combine these two. So we use qdef again to define a new schema. We want to see the resulting schema by combining these two. And you see that it accepts it, and it has a range, which is the intersection of these two, right? So it basically shows every possible value that is accepted by both schemas. So now we're combining two schemas with conflicting values. Let's see how that looks like. So we want to see the schema. Let's do it that way. And then we look at view, and it shows that basically there's bottom means it's an error. And basically it says for view, we have, it requires to be both a Boolean and string, which of course is incompatible. So here we basically see that it rejects this. There's no possible values that matches both schemas. So now the question you want to ask yourself is like, what's your source of truth if you are trying to have a single representation for all validation? So let's look at some examples in the wild. So Kubernetes uses Go as the source of truth, and from that it generates protobuf and OpenAPI, which is a valid choice, I would argue. But there's alternatives. So Istio, for example, basically has protobuf as the source of truth, which is not as expressive. Right. So the idea they have there, so they convert the protobuf to Q, and then from Q to go to OpenAPI. So this means you don't have constraints for now. But the idea was that down the line, they can either inject Q constraints in protobuf, which Q allows, or you have Q files inserted into the pipeline, and maybe at some point they can also generate Go from that. So one reason why you would want to have Q in the middle as well is that Q actually converting protobuf to OpenAPI is far less trivial than you might think. So they can actually let Q do the heavy lifting there. So let's give an example of using Go as a source of truth for types, but Q for validation. So here we have the Go types of the files we saw earlier. So let's focus on table. So if you write some validation logic for table, it could look something like this, right? Let's say we only want to restrict what's a valid range for the number of seats. So now what we can do is we want to have these constraints declaratively in the source code, in the Go source code, in Q. So you could do this like this. So I'm going to the live demo immediately, where this is copied. So basically what we do, we import the Go codec package in the Q repository. We add these Q constraints, And then we call, instead of the original Go validation logic, we call this Godec validate. So let's see what you can do. So here we have a test with the wrong input value, which calls validate. And if we run it, indeed the test will fail. So 12 is larger than 10. So let's correct this. Run it again, and then indeed it's now correct. So yes, this is cute, but now let's see, can we actually now derive the OpenAPI from this Go code? Another rhetorical question. So we have the command q get go for that, and normally puts it in some repository, but now let's say we want to have it locally generated. Let's open the file and see what it produces. And essentially, it produces this same definition we saw before, but now with this expression, the Q expression interjected, right? Like as is, there's no normalization or whatever. So we can run qdef again to simplify this. So let's do that and let's see what it outputs. My past self could have been a bit faster. So here we see qdef. So it outputs it, and it simplified the uinteger, uint and smaller than 10. So here you get the OpenAPI from it. And then maybe it's easier to do YAML. So if you do out OpenAPI plus YAML, you get the nice YAML output of, of what is encoded in the Go code. So the question is, can we also then generate this from within the Go code itself? Because if you generate the OpenAPI, of course, now you have to make sure this is served somewhere, maybe link it into the Go binary if the Go binary is serving it, or statically serve it somewhere else. And if you have a good CI/CD pipeline, that's fine. But maybe initially you want to generate it from within the Go code directly. And this allows you to do that. It extracts, in this case, just table, extracts the type, creates a QAST from it, compiles it, generates the OpenAPI, pretty prints it. And then I do a fail, so it actually shows up in the error in the test. So let's print that out, and you get the OpenAPI from within your Go binary, right? So there's no anything extra you need. It can be handy. So this always fully expends the OpenAPI, which might not be what you want, but could have an option for that later. So now the question is this always the right thing to do? So maybe we should go from Go to Q. So for example, Istio has a lot of validation logic. And it's really a pain to convert this to anything else. So can we automate this process? So the idea was, so Go has some pretty cool tooling, or very cool actually, in the SSA package, where you can create this intermediate representation between Go source and a compiled Go program. And we can use this to analyze the behavior of a Go program. So the idea is, can we use this to extract Q facts? So now we have another demo. So what you see here, I removed the Q constraints, added validation code, like Go validation code back. And now we're going to see, so let's first see what happens if we run Q get go again. So as you can see, the file is removed. So we're running it again. Let's show it and see how it looks now. And you see that the constraints are gone, right? Because right now the Go code doesn't have any Q annotations. Now, we want to put these constraints, we want to extract these constraints as well. So this is not checked in yet, but I have this option now to qget where I can specify, do an SSA analysis, and then write the results to this file. So let's do that and see what that produces. So let's wait for a second. So we have the output here. So this is basically all the facts that it could gather from the Go code. So what we see here, because Go has C-style semantics for logic, right? There's actually two paths to this error condition. One if the first one succeeds, and one if the first one fails and the second condition succeeds. And that's what you see in the result is the inverse of that logic here, right? So this by itself is not that useful. We want to combine this with the table that we already have, right? So here we see just integer, and we can do that by just merging it. It's in the same package. So we can combine this just using qdef on the current directory, which will merge every file from the same package. And let's open this in a file so you can see it pretty printed. And what you see here is that we have the same schema that we had before with the same kind of conditions. that we saw earlier. Let's open the original source code file, and you see indeed that this matches the Go code, right? So of course, our goal was OpenAPI, so let's generate that for good measure. So here we have the OpenAPI with constraints, without any declarative Q notation. This is only from Go code, right? There's nothing else. So what are some of the findings of this? Well, so extracting this is pretty nasty. So you have, it's actually logically better to look for the failure cases and then negate it, but that creates some pretty messy constraints, right? But Q normalizes this out of the box. Like I didn't have to do anything for it to generate this nice, like end schema. Another thing that I found was, this is some pretty complicated stuff, but the Go error model really helped here, right? Like, so finding the failure points in the SSA tree was actually quite simple, just because the error model is also so simple. And usually if something is simple for machines, it's also simple for humans, right? So that was a nice little data point. So right now the coverage is pretty poor, but I analyzed what would be possible using this approach. So for the Istio validation code, I had 100% accuracy in detecting what is validation code. That could still be improved, but 100% seemed good enough. And I was able to achieve 90% coverage. So that means for all the possible code paths, in 95% of the cases, I was able to determine would it terminate with an error or not. So the next question is also, can we translate this into error messages, right? So that you don't have to import the error messages to Q as well, or handwrite them. So this will be a future topic of research. So finally, what are some of the caveats? Well, so Q is working itself to production readiness. So I wouldn't use necessarily the validation online, right? Mostly for performance reasons. But using the offline generation is generally fine. And this is what Istio uses. So there is a new release imminent with the new evaluator, which should make performance a lot more reliable and predictable. So also keep in mind that both Q and JSON schema and OpenAPI are all in flux. Probably OpenAPI or Swagger is the most stable of these, but OpenAPI is based on JSON schema, so they're also forced to adapt to this moving target as well, right? So this can cause some confusion here and there. What also would be nice, which doesn't do right now, so actually generate Go code from the Q constraints. And with that, I'll open it up for questions.
Awesome. It was actually a very, very interesting talk, like I suspected.
Thank you.
This is actually something that we were analyzing at my last work, a similar tool, what would be a tool for this, and we didn't run across this one. So I am going to look into it after the talks. Thank you so much for your talk. And yeah, now if there is anyone who would like to ask some questions, yes, here there is a question. How far along is Q with integration to protobufs?
Yeah, so basically I've been working on Q very much on a demand-driven basis, right? So I implement what people will directly use and what's needed. So the protobuf to Q conversion is in a pretty advanced state when it comes from proto definitions, but proto values is not implemented yet. Really shouldn't be that hard, but as I said, I sort of focused on where there are actual users, and I know there will be. This is a little bit chicken and egg problem. There will be users for proto, but text messages, but yeah. But actually, so mapping proto, so the protobuf definitions to Q is actually the hardest part. And that has been in use for quite large protobuf sets in Istio. And, it's been working reasonably well, or quite well.
I can imagine. And there is another question that is not so related to the talk, but where is your T-shirt from?
This is from a very old Go, I don't know actually. I think it was a Go team T-shirt, but it's old, it's very old, yeah. I think it's, maybe it was from a Go conference as well, could be. I think so, actually. Yeah.
So the person who asked may not be able to find it, but...
it will be tricky, yeah.
We have another question. How do you share the schema between the client and the server eventually? OpenAPI? OpenAPI, yeah.
Yeah, so OpenAPI would be a good one to do it. So you can, as I said, you can serve it directly from the Go server, right? But typically is to just statically serve it somewhere. That would be the more typical thing. Although you need to have a good CI/CD pipeline for that. But yeah, that would be a possibility.
Another question says, I could use this for now. I'd be asking for customized and translated error message, if you hadn't mentioned it already. Is that feature far away from on the roadmap?
Actually, this is a very good question. Yeah, so this has come up many times, and if you want to support anything serious where you do online validation, you have to have custom error messages, right? So, so this is something I wanted to wait for the new evaluator, because the new evaluator, so custom error messages are doable, but somewhat tricky, right? Like logically, it's all the same error, so you need to make sure the logic engine doesn't discard the error somewhere along the way, and this is much easier to do with the new evaluator. So it's definitely an important feature. It's not there yet, but I have an implementation, but threw it away again because I wanted to do it better. But yeah, so definitely on our minds, high priority. Yeah.
Relatable.
Yeah.
And another question: is there a way to get the path to which values do not validate for deeply nested structs? For example, restaurants, tables.
Yeah. You can do that. Yeah. So Q is actually, well, yes and no. So to some extent, it's much more expressive than OpenAPI and JSON schema. So it has references. You can, very much like Go. So yes, you can do that. It doesn't do negation of structs yet. Like that's logically very, very perilous, right? So this is also something the new evaluator will be handled better. That's like non-monotonic logical behavior, right? Which OpenAPI does. But so it's not mapping one-to-one, but it's like we're getting very close soon to map all of OpenAPI plus do what Andre asked, right? Like this, yeah. But yeah, that what Andre asked is possible for sure.
Awesome. Then, are there any other questions? Maybe? No? 3, 2, 1.
I'll be in the group discussion thing afterwards. So if you have any more questions, feel free to ask there.
Awesome. Then thank you again so much for your time. It was a wonderful talk. And well, see ya then.
Okay, thank you.